The history of using metals can be divided into several stages. When people first used gold, silver, copper, bronze and iron. Gold is chiefly distributed in the gravel of riverbeds. As gold is rarely combined with other substances, it was discovered at a relatively early period. Gold has a very unique colour and is found in extremely small amounts. Therefore, it is considered a precious metal. As gold is relatively soft, it can be moulded into different shapes. At the same time, its low hardness also renders it unsuitable for making utensils. Therefore, since earliest times, gold has been mainly used to make decorative items. Most silver is found as a mineral where lead also exists. But some silver is also found on its own. Just like gold, silver is a rare metal. Throughout history, silver has always been used to mint coins. As for copper, it is one of the metals that is widely used in making daily utensils. One of the reasons for this is because it is available in greater quantities than gold or silver. Strictly speaking, a lot of utensils are not made from pure copper, but rather from its alloy, bronze. As bronze is much harder than pure copper, it can be more widely used to make a variety of utensils. Finally, let's take a look at the metal iron. The amount of iron on Earth is relatively large, and it is also much harder than a lot of other metals. Therefore, it is widely used. The history of using metals is closely related to the level of difficulty in extracting each metal. The easier each metal was to extract, the earlier it was discovered and used.
Only a few metals such as gold are already pure, faultless, and shiny bright when extracted from the Earth's crust. In fact, most natural metals have combined with carbon, oxygen, sulfur, or other elements and exist in the form of metal ores. Sometimes these ores are no different from ordinary stones. Metal ores mainly consist of oxides, sulfides, halides, carbonates, and sulfates. Ways of extracting metals from these compounds may vary according to the type of ore, but basically, from the point of view of chemistry, the change involved is the same. When metal has combined with other substances in an ore, it is necessary to find a way to separate them so as to extract the metal. Take lead oxide in lead ore, for example. It is a compound of lead and oxygen. If we heat it together with carbon after a certain time, carbon will combine with the oxygen in the lead oxide to release carbon dioxide, and lead will be left behind. Let's place some lead oxide and carbon powder onto a container. And heat it at a high temperature. After a while, some sparkling silvery substances can be observed. This is lead.
Metals are useful in many ways. For instance, aluminium is used to make airplanes, space shuttles, and the outer layer of trains. This is because aluminium has a low density, but is very hard. Meanwhile, it is also a good conductor of electricity. So it is used to make high-mounted cable too. Soft drink cans, heat-insulating paper used in kitchens, window frames, and laser discs are all made from aluminium. Copper is very good for conducting electricity, and it is also highly ductile. Therefore, it can be used to make electric wire. As it can resist air contamination, it is used to make pipes. Kitchen utensils can also be made from copper, since it is a good heat conductor. As for gold and silver, other than being used for minting coins and making decorative accessories, their shininess enables them to act as good reflectors. The solar panels on the surface of satellites are tinted with gold, while the backs of glasses are tinted with silver. Lead can be used to insulate against radiation. Sometimes, radiology operating staff put on special protective clothing made from lead, so as to avoid absorbing unnecessary radiation. Burning magnesium produces dazzling flames. Therefore, it can be used in making fireworks. Mercury is the only metal in liquid form. It can be used in a thermometer. Titanium is a metal with very low density. It can therefore be used to make ultrasonic airplanes. In both low and high temperatures, titanium is still extremely hard. It is therefore used in making fans for jumbo jets, as well as magnetic drums in video recorders. Let's look at this copper wire. Hang it onto this rack and connect its lower end to this weight. Here is a pointer. Right now it's pointing to 50 centimeters. We then add another weight onto it. The pointer will go downwards, indicating the copper wire has become longer. We describe the metal copper as ductile, meaning it can be stretched. This characteristic is then called ductility. This equipment is used to measure ductility. It is computer operated. First of all, let's place the metal into position. This part is fixed. Enter the required force and speed into the computer. Start the operation. The part clipped to the metal specimen will be pulled upwards until the metal breaks into two. The entire process will be stored as data in the computer, which will then calculate precisely the ductility of the relevant metal. We have all seen how workers bend metal tubes or metal plates into products of different shapes. The characteristic of metals to change shape under force without breaking is called malleability. We can describe a piece of metal as malleable. This equipment is for measuring the malleability and hardness of metals. This is a drill set with a diamond. It is used to put force on the piece of metal specimen. Place it onto the equipment and put a piece of metal here. Turn on the revolving plate. The metal specimen rises slowly until it is crushed against the diamond drill. By measuring the degree of crush on the surface of the metal, we can ascertain the hardness and malleability of that metal. If it is only slightly crushed, its hardness is rather high and malleability low. In other words, its shape will not change easily. Conversely, if it is very much crushed, its hardness is low and malleability high, meaning it can change shape easily. Apart from being ductile and malleable, metals are usually good conductors of heat. Metals can usually transmit electricity and are therefore good electric conductors. All in all, the uses of metals are very much related to their characteristics. The main way to improve the quality of metals is to make alloys. When one metal combines with other elements in a special manner, an alloy is formed. Bronze is an alloy made from copper and tin. It is much harder and more practical than pure copper. It is made from adding approximately 10% tin to pure copper. Brass is an alloy made from copper and zinc. It is normally used for making electronic parts and lock materials. The solder used in welding electronic parts is alloy made from lead and tin. Modern living is very dependent on the use of steel. All kinds of machinery, construction materials, bridges, vehicles, ships, as well as household products use steel as their main component. Steel is an alloy made from iron with other elements. It is much harder than pure iron. There are all kinds of steel. For instance, the one which consists of approximately 2% carbon with iron is called carbon steel. In ancient times, one way for creating a sharp blade was by placing an iron blade onto burning charcoal for a long time. This allowed carbon to penetrate into the blade and form a hard outer layer of iron with carbon covering the softer iron inside. That is, a steel surface. Repeated beating is often required to enable an even distribution of the carbon into the iron. In such a way, a hard and sharp blade can be produced. In daily life, the most commonly used form of steel is stainless steel. It is mainly an iron-chromium alloy, with an average of not less than 12% chromium. Stainless steel was discovered accidentally by British metallurgist Harry Brearley in 1913. At the time, he was testing ways of making steel alloys to see which was most suitable for guns. Several months later, most of the abandoned alloy specimens became rusty. Only the one containing 14% chromium remained rust-free. Because of this discovery, we can have all kinds of stainless steel utensils nowadays. Normally speaking, Once the shape of a metal has undergone a rather dramatic change, it is not easy for it to revert to its original shape. Yet this metal wire, bent in the shape of the letters I, C, E, is different. How is it different? Let's first stretch it flat into a straight line. Then put it into hot water. Watch carefully. The metal wire reverts back into the shape of ICE quickly. Isn't it amazing? To watch the transformation process more clearly, we can use a hairdryer to blow hot air onto the flattened metal wire. Then we can witness the transformation process slowly. A metal which can memorize its shape is called shape memory alloy. No matter how much its shape has changed, once it reaches a certain temperature, it will revert to its original shape. Shape memory alloys can memorize different shapes. This intelligence originates in the different phases of the alloys themselves. What do phases mean? What we commonly see in daily life, ice, water and steam, are the three phases of water. Different phases indicate different arrangements of particles inside the relevant substance. While in solid state, the shape memory alloy possesses two phases, one at a certain temperature and the other at another temperature. Shape memory alloys have widespread uses. For example, in dental plastic surgery, these alloys can be used.
This shape memory alloy wire has already recorded the proper arrangement and positioning of the teeth. When we place it onto the braces, the wire slowly sets the teeth into proper position. In the process of dental plastic surgery, we first place a brace onto each tooth. We connect each brace with the shape memory wire. The function of this wire is to slowly fix each tooth into the desired position. This is the original shape of the shape memory wire. When it is connected to the patient's teeth, its shape changes into a curve. However, when it is exposed to high temperatures, for instance, when the patient takes hot food or drinks, the wire will revert into its original position. In such a way, the rather irregular position of the teeth will be gradually corrected.
Some alloys can be used to make superconductors, meaning materials extremely good at heat conducting. Superconductors are used in high-tech products like magnetic levitation trains and medical appliances like magnetic resonance imaging equipment. Space alloy refers to the alloy made with space technology. It is much easier to obtain a super vacuum and zero gravity in space than on Earth. Under such a state, two or more substances of different densities can be mixed homogeneously without causing any convection. As such, relatively perfect alloy crystals can be developed. How are metals recycled and reused? Many metal manufacturing plants have started to use recycled metals. This symbol on this soft drink can indicates that it is made from recycled metal materials. Collected aluminium cans will be sent to the assembly plant and crushed flat by huge machines. After being processed, they will be recycled and used again. The recycling processes for different metals are different. This is why the metal waste needs to be separated into different categories. Canned foods are plated with a layer of tin to avoid iron rusting. As tin is very expensive, it is necessary to recycle it for reuse so as not to waste our natural metal resources.